And the book calls this the multiplication rule. And I'm not going to call it anything. This should be working. Multiplication rule. Multiplication rule. And why they call it the multiplication rule is because of this. Let's take a look here. We'll do this out and then we'll talk about it here. Let's say you flip 2 coins. Or we'll flip 1 coin twice, it doesn't matter. What is the probability? What is the prob of getting both heads? In other words, in math, we'd write it like this. Probability of, parenthesis, a head, and then a head. One way to think about it is you can always make yourself find the sample space, list all the possibilities here, and this is how I would do this one. On your first flip, or your first coin, it doesn't matter what you call it. What's your probability for your first coin? You can either get a head or a tail, right? And then, if you branch off of that, with what happens with your second coin, your second toss, it doesn't matter, coin, you can also get a head or a tail, right? So each one of these you can branch off to a head or a tail. First coin, you can get a head and then get another head, you can get a head and another tail. You can start with a tail, get a head, and then get a tail and a tail. So your sample space, I will draw it out. You can get this, a head and then a head. HH. You can start off with a head and then get a tail as your second one. Okay. You start with the tail and then get a head, or you can start with the tail and then get a tail. So there is what we call the sample space. That's all the possible outcomes. What is the probability of this HH happening? Well, you look at this and you go, I have a total of 4 different possible outcomes. How many of them are the HHs? Just 1. So my probability is 1 out of 4 that when I flip 2 coins or flip a coin twice, I'm going to get head over head. Now you don't really want to have to draw and continue to write down sample spaces. Okay? There's an easier way to do it, and that's where that multiplication rule comes in. If I am looking for the probability of getting a head and then a head, okay, the rule of thumb is that the probability of this happening is the it is the 2 probabilities multiplied together. Or I guess I should say the product of the probabilities. And that won't make any sense till I explain this, so. Write that down and I shall enlighten you. That product of probability means this. The probability of a head/head happening is the same thing as the probability of flipping a head for the first one times the probability of flipping a head for the second one. Which, if you think about a coin, what's your probability of flipping a head? 1/2, because each one head, 2. What's the probability of flipping a head? Same thing. The probability of both those happening are their 2 probabilities multiplied together, which we got, which was 1/4. We'll do a couple more examples so you kind of see that. Let's change it up. Let's make a spinner. Let's say you have a spinner that has 1, 2, 3, 4, and you are also flipping a coin. Let's do Abraham little bushy beard. Not a bad Abe, is it? The probability of spinning a 4 and flipping a tail. You could sit down and make up all of the sample space for all this, which would look like this. Well, if you spin the spinner, you can get a 1, a 2, a 3, or a 4. And then after you spin a 1, you can get a head or a tail. After you spin a 2, you can get a head or a tail. After you spin a 3, you get a head or a tail. After you spin a 4, you get a head or a tail. So the sample space, you get a 1 head, a 1 tail, a 2 head, a 2 tail, a 3 head, a 3 tail, a 4 head, or a 4 tail. Okay. How many 4 tails did I get? Just 1 out of what? What was it? 6? No, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, you can sit down and do that whole sample space thing, or you can look at this and go, oh, what was my probability of spinning a 4? What's the probability of spinning a 4? 1 out of 4, right? And multiply that by the probability of flipping a tail. What's my probability of flipping a tail? 1/2. The probability of both of those happening are those two probabilities multiplied together, which is what we got, 1/8. You don't want to have to sit down and draw up the whole sample space for all of that, because it could take you forever depending on what we're doing. For example, let's say in a deck of cards, what's the probability of drawing a jack of hearts out of a thing and then spinning on a spinner, spinning an 8? 1, 2, 3, 4, 5, 6, 7, 8. Alright, you certainly don't want to draw up the whole sample space for this, because you would have 52 possibilities here in your deck of cards. And then you would have, off of each of those 52, you'd have 8 little branches coming off, because that'd be your second thing. You really want to be able to do this. What's your probability of drawing the jack of hearts? Somebody? How many jack of hearts is in there in the deck of cards? Just 1 out of how many cards? 52. So there's your probability of that. And you then just want to multiply that by what's your probability of spinning an 8? 1/8. The probability of both of those happening are what you get when you multiply those two probabilities together, which happens to be 1 in 416. It's not going to happen very often that you draw the jack of hearts and then spin an 8. So knowing that, Laney Kavarik, you would say, let's think about the lottery. What is that? And I don't, honestly, I never played lottery, mostly because I just never win when I do anything like that. So why throw money after that? Anybody know anything about the lottery? How many numbers do you have to pick? Anybody? I'm glad you don't know. I think if it's either 5 or 6, is it not?
6.
Let's say you have to pick 6 numbers. Okay, and what are the range numbers from 1 to what?
9.
Huh? No, it goes up to like 50 or 60, doesn't it?
Yeah.
9.
You can pick 2 digit numbers, Elijah.
Here, well, let's look. Let me Google what today's winning lottery numbers were.
Alicia, well, he wins the lottery. He said
Wait, there was just that
all
$400 million one.
I've never seen that. But I've seen it on television.
Let's just say this says 65, so it has to go up at least to 65. So here you go. This shows you your chances of winning the lottery. Wait, how many numbers? There was 5, wasn't there? How many did I show up on the screen? Wait, let's go back. I'll go back. 1, 2, 3, 4, 5. There are 6. 6 numbers. I don't know, is that the Powerball or something? I don't know. 6 numbers. 1 through 65. So that would be the probability of picking the first number, the second number, the third number, the fourth number, the fifth number, the sixth number. Which means it's all of their probabilities multiplied together. Probability of picking the first number times the probability of picking number 2. Just put 2 in there. Times the probability of picking the third number. Times the probability of picking the fourth number. Times the probability of picking the fifth number. Times the probability of picking the sixth number. Well, how many different choices were there? 65, right? So the probability of you getting the first number right is 1 out of 65. Now the next one's not quite so bad because you already picked a number. You know they do the little drawing with the balls. They don't put the ball back in. So the second number, there's only 64 numbers left. And then after that, there's only 63 numbers. And then there's only 62. And then there's only 61 numbers. And then there's only 60 numbers left by the time you get to the fifth. So your odds of picking the next, you get the first one right, your odds of picking the next one right go up by just a little bit here. Yes. Yeah, but here we go. So we got, and I'm not going to do the math, I'm going to grab my little tools here. So your probability of winning the lottery is, let's do it, 65 times, well, all the ones on top give you a 1, right? Multiply all the bottoms together, 65, where's my times? Times 64, times 63, times 62, times 61,
I like that.
times 60.
I'll take those off.
That's, something's not quite right there either with that. I don't think it's quite that bad, but according to this, what is it? Let's just say that's a 6. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6 with 10 zeros after it. 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. About 1 in 60 billion, but that's not right. It's only like, it's only 600 and some million for some reason. Maybe this is a different lottery thing or whatever. Your odds of winning the lottery are incredibly small.
Hey, the person who won it today, dream big. October, there's a person who won it today.
Luck is with Kim. There's always somebody who wins it. It might as well be you, guys.
The
The truth is, you do have as great odds as somebody else. It's just that neither one of you are very good. Now, write this down because we're talking about dice here. If I asked you what is the, and here's where you have to be careful. What is the probability of rolling 2 dice and getting a 12, or well, let's say a 7? You have to be careful with this because you're rolling 2 dice that give you multiple combinations. And anytime you talk about 2 dice, really the only way to think about this is to go back to a table. When you roll dice, your choices are you can roll a 1, a 2, a 3, a 4, a 5, and a 6, right? That's your on dice number 1. And fortunately for you, your dice are very much alike. You can roll a 1, a 2, a 3, a 4, a 5, or a 6 on dice number 2. So here is your table of possible dice combinations. And you just have to look at this like this. If you roll a 1 on one and a 1 on the other one, that's a total of 2, correct? A 1 on the first one and a 2 on the second one is a 3. And you can see the pattern, it just keeps going up here. 5, 6, 7. I can't get the number 4 right. A 1 and a 2 gives you a 3, a 4, a 5, a 6, a 7, an 8. A 4, a 5, a 6, a 7, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, 8, 9, 10, I did those kind of fast, but you can see they just come, if you roll a 3 on one and a 4 on the other one, you get a total of 7. That's all this table shows you. A 6 on one and a 6 on the other, you get a 12. So to find the probability of rolling a 7, okay, you have to notice, first of all, how many total combinations are there, which makes sense because you're rolling 2 dice, dice 1 and dice 2. That means there are 36 total combinations because there's 6 on each. Okay, but because you can have different combinations that make up a 7, that changes kind of how you look at this thing here. How many different ways are there to roll a 7? Well, you can have this, 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 or this. How many 7s? 1, 2, 3, 4, 5, 6. So your probability of rolling a 7 is 6 out of 36, or 1/6. There's a greater probability of rolling a 7 than any other number on the board, but still your chances of rolling a 7 are so-so. What's the probability of rolling a 12? How many 12s do you see on our table of 36, Elijah? Yeah, just 1 in 36. You are not going to get 12 very often when you roll 2 on there. Same thing with 2. There's only one way to get a 2, that's snake eyes. Okay, again, that's only going to happen 1 out of 36 times or whatever. And that's why when they play these crazy dice games at wherever it is, Las Vegas, what is the one where they roll everything up against the wall? I don't know. I mean, you get more money if you bet these numbers that don't happen very often than you do with 7s, and it's all figured out. But could you imagine making a tree diagram of all of these? It would take up a whole piece of paper. But if you've got the table drawn here, you can kind of, what if I asked you this? What's the probability of rolling an even number when you roll 2 dice? That should almost be logical, but if you have to count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 36, which is half, which should have probably come to mind anyways, because half numbers are odd and half numbers are. I think that would probably, you would probably survive.